Well, here's the next one. Go ahead and pause it if you don't want to hear it. The answer is back to you. Back to you. All right. That's kind of cool. So this last section of this worksheet here is asking us, telling us first of all that the second derivative of a function, and if we call the function y equals f of x, can be written like this: d with a little looks like an exponent there, 2, and dx2. The way you say this though is the second derivative of y with respect to x, or f double prime of x, and then the excuse me, the third derivative can be written like this, or should say there should be 3 little lines there. It looks on mine like there's only 2, but there should be 1, 2, 3. So that's the third derivative of f, and or yeah, third derivative of f of x, or f triple prime, you could call it that. But nevertheless, we've just basically done lots and lots of problems on finding the derivative of a function, and which showing you guys that the derivative of a function f of x can also be a function. You can graph that function as well. We'll get into that later on. But nevertheless, the second derivative of f of x will just be take the derivative of f of x and then take its derivative. So it's like you're taking a derivative and you're just repeating that process. Okay. And by the way, something that you probably don't know, that the third derivative is called the jerk. Okay. And we'll talk more about that when we get into section 3.4, so never be a third derivative. Second derivative of a function is the derivative of the derivative, and so yeah, okay, it says that right there. So you've got your notes, if you forget what I say. For each of the following, find f double prime of x. Okay, so f prime of x, you have to find that first, and I thought we did this one already. We did, almost. There's one just like this up there. But the derivative of f of x is the derivative of the first term, and the derivative of the first term is 8/3 times the derivative of x cubed, which is 3x squared. Okay, minus 5 times the derivative of x squared. That's again the constant multiple rule. The derivative of x squared is 2x, and then minus 7 times the derivative of x, which is 1, and then times minus the derivative of 1, which is 0. Okay, let's clean this up a little bit. We have equals 8x squared minus 10x minus 7. So that's our f prime at x, or of x. And then if we want to find f double prime of x, we're going to just take the derivative, of each of these terms. The derivative of 8x squared is, and I think by now we can get away from saying 8 times the derivative of x squared. Okay, 8 times the derivative of x squared is 8 times 2x. So we always end up taking this exponent and multiplying it by the number out in front, which is the way I'm going to start doing it from now on, unless you tell me that you'd really like me to keep it with the other way. You know, writing it out like this: 5 times the derivative of x squared, and then multiplying it out. But we can do this all in one shot. 2 times 8 is 16, times x to the 2 minus 1, which is 1, minus 10x, it's the derivative of 10x is just 10, and then the derivative of negative 7 is just 0. So we have the second derivative equaling 16x minus 10. That's the second derivative. When you start getting into quotients, that's when it starts to get to be kind of a pain, and so to alleviate that problem, only use a quotient rule when absolutely necessary. I'm going to use a property of real numbers that you learned way back when you added fractions. If you had a over b plus c over b, if the denominators are the same, then you can combine the numerators, a plus c all over b. Okay. Well, here we have the a plus b plus c all over d, let's say. It's probably more confusing than just looking at it. We have 3 terms in the numerator all over 1. So we're going to split that up. We're going to write it as each term over that denominator. Okay, each term over the denominator. Each term over the denominator. Just like just reversing this process that we did here. Okay, and so anyway, cleaning that up a little bit, f of x we could write as x plus 4 minus 2, and then I'm going to write this as 2x to the negative 1. It's much easier for me to see how to find the derivative when I have it written as a power of x. So therefore, f prime of x would be 1, and then negative 2 times negative 1 is 2, so plus 2 times x to the negative 1 minus 1. So again, we're using the power rule. Negative 1 minus 1 is negative 2. And that's f prime. So we can easily find f double prime of x, which is just negative, the derivative of the 1 here is 0. And then the derivative of 2x to the negative 2 is negative 2 times 2 is negative 4 times x to the negative 2 minus 1, which is negative 3. We could clean it up if we want, write it as with a positive exponent, and we can write it like that. I wonder if you hear the dogs in the background like I hear. Yeah, these little yipper dogs. Those aren't even ours. We've got our own yipper dogs, but they don't yip all day. I don't even know if you can hear them or not, but I can. And when I'm hungry, it starts really getting on my nerves. So I'm going to try to not show that to you guys other than I already told you. Alright, let's do this one. If this starts getting a bit cumbersome, then we're just going to stop. Let's just see how it goes. We have the derivative of a quotient, so we're going to use the quotient rule. And the quotient rule is, again, the low d high. So x plus 1 times the numerator, derivative of the numerator, minus the numerator times the derivative of the denominator, okay, over the denominator squared. So this is going to get a bit cumbersome, but what we have here is x plus 1 minus x, which is just 1, over x plus 1 squared. Okay. Well, let's write that like this. 1 over... there's so much an easier way once we get to section 3.6, by the way, to do this problem. X squared plus 2x plus 1. And I'm even going to rewrite that. Oh, no, I can't. Alright, so we're going to leave it alone. Yeah. So you'll learn a better technique than what I'm going to show you now, but this will at least give you an idea of just some practice on how to find the second derivative. So anyway, the second derivative of this function is low. We have this function down here, low, x squared plus 2x plus 1. D high, now the numerator is only a constant, so the derivative of that is 0. Okay, minus the numerator multiplied by the derivative of the denominator, which is 2x plus 2. Okay, derivative of x squared is 2x, derivative of 2x is 2. All that, which now this term is going to go away because it's going to be multiplied by 0. All that over the denominator, which I'm going to rewrite it like this, x plus 1 squared, which is x plus 1 to the 4th. And I really don't want to have to simplify that any more than what I see there, so we're going to leave it alone. And man, that d, that's looking a little daunting here. Let's clean it up a little bit. Let's write it as 4x to the 1/2 minus 2x to the negative 1/2. Let's just use the, oops, didn't even show you. Let's use the power rule. Okay, f prime of x is equal to, now 1/2 times 4 is 2 times x to the 1/2 minus 1, and 1/2 minus 1 is 1/2 minus 2/2, or negative 1/2. Okay, and then we have a negative 2 times a negative 1/2, and that's positive 1, x to the negative 1/2 minus 1, which is negative 3/2. Okay, that's a little bit more than I like to do in my head, but I'm lacking a little room down here, so if you really need to, use your own piece of paper and write out the steps. But this is what you should have at the end of your f prime step. So we have to do one more. Okay, so f double prime, but it's already set up for us. It's already in the right position for us to go ahead and find the derivative of this function, which is the derivative of f prime, which again is the second derivative, or f double prime of x. Alright, and so after this entire, I guess this is the third video. After the third video, you should be pretty good at finding the derivative of any of these functions, and you can see that a lot of times we're just using the power rule. It comes up a lot. In fact, it's probably the rule you'll use most often, but you definitely need to know the product and the quotient rules as well. So anyway, let's finish this up here. 2 times negative 1/2 is negative 1. X to the, again, negative 1/2 minus 1, which is negative 3/2. And then plus 1 times negative 3/2. Well, that's minus 3/2 times x to the negative 3/2 minus 1, which is negative 5/2. Okay, I feel kind of bad not showing you every little step, but then I get so many people saying, Mr. Hawks, you're taking way too long to explain this one thing. And but again, you know, you have the videos here. What I would encourage you to do if you're getting stuck with the algebra is write it out yourself and just understand, you know, you've got this, just a quick review of the rules here. The derivative of any constant times x to any power, okay, with respect to x. This is the one we're using most often, if you've noticed. The n and the c always get multiplied together. So you have c times n, and then you multiply that by the x, and then you just subtract 1 from the exponent. So this is the main rule that we keep using over and over again. Okay, and we use this in just about every single problem on this page and on the last page. And so, again, if you're getting bogged down and you understand this, then you're probably kind of messing up or maybe forgetting some of the algebraic rules, like the laws of exponents and then adding and subtracting, and maybe you're even making some mistakes when you're trying to subtract 1 from negative 1/2. I see that a lot. And so I encourage you to be diligent and also be thorough with your math. Really think through every single step. Keep repeating this rule to yourself. This times this, all right. And then you just keep repeating the rules over and over again. And that's what you see me do, but this is how I do the problems if I'm doing them without explaining them to students. I make sure that I think through and I kind of say out loud, if I'm taking the derivative of this term here, 2 times negative 1/2, and I picture that, okay, that's negative 1. And I could show every step, but there's just not a whole lot of room here, and I do want you to make sure you fill in those details if you need to, and that will give you extra practice. If I show you every single little step, then some students think that they've got it, but they haven't taken the time to go through that, and they don't really have it. So it's kind of a fine line there, but anyway, come in and see me if you really need me to show every little step, and I'd be happy to do that. I just think that this is the most efficient way, and you may or may not agree, but come see me if you wanted to just kind of work through those little steps. Okay, and that's going to be the last video for tonight, so have a great night, and I will see you tomorrow.